Hello, everyone, and welcome to a new episode of the Routing Loop. Thank you for joining us on this fine Wednesday. It's Wednesday today. I keep saying Thursday for some reason. I'm closer to the weekend, I think. Um, on this fine Wednesday morning at 11 a.m. Pacific time. I always mess up time zones, so I don't know what the other time zones time is. But yeah, thanks for joining us, folks. I'm Alex. I'm a networking specialist solutions architect with AWS, long-standing host of this show, together with Tom here. Tom, do you want to go ahead and introduce yourself?
Sure. Hey, everybody. Tom here. I'm also a networking specialist solution architect, actually on the same team as Alex. So we both work as part of the service team. Excited to be here. We have an interesting session. We recently had, I think both Alex and I have a lot of conversation with independent software vendors, so ISVs as we call them for short, which are kind of organizations, companies that have SaaS applications or have access patterns where they're either presenting an application to their end customers on AWS, or they want to consume some resources that their end customer is offering, maybe a database, maybe some data source. So there's a lot of those kind of use cases, and they get very interesting. So we have, I guess, for you today, like a bit of I wouldn't call it a deep dive, but it's going to be like a high-level overview, 10,000 level view of all the different ISV access patterns that we'll try and unpack. So we can go as deep as the chat wants. We'll follow the rules of the chat.
Yeah.
But we'll start very high level, just to kind of like, hey, here is the pattern, and here is some of the things to consider about it.
But before we dive into that, I think it's a really exciting topic. And as you said, Tom, we have a lot of conversations with customers about this. Also, really excited to be on the same team with you right now. Like this is the first time we've been on the same team since both of us joined AWS. So really excited for that. Um, Tell us, everyone, where you're joining us from. We see some long-standing fans of the show here, Hitherings, and other folks have joined. Please do let us know in the chat. I am in San Francisco. For those of you who have been following us so far, know that I'm based here in downtown San Francisco. It's a pretty gloomy day today. Winter is coming, I guess. Um, but yeah, let us know where you all are joining us from. Tom, where you are now? I know you moved, right?
Yeah, I'm up to San Francisco, and I still go to the San Francisco office every once in a while. But I'm in Sonoma, so that's a little bit north of San Francisco. That's
Got
the
it.
the wine county, the other wine
Nice.
county.
Nice. You made the right choice there. We see folks, we see the Malta community day joining us. Thanks, folks, for joining us. We see folks watching from LA and from Guatemala. Oi, saludos.
Yeah, I've been to
um,
Guatemala quite a while ago. I think like 15 or 16 years. It was a fun trip.
oh, nice. Pretty cool. Pretty cool. I haven't been there yet, but yeah. Um, Cool stuff. So we're going to be talking about modern connectivity patterns for ISVs on AWS. And I think Tom, you're gonna take us a bit through some of those patterns. And the goal for us here today is to answer any and all of your questions in the chat. So please do let us know if you have any questions. The goal is to make this a super interactive session. I will start asking Tom a lot of questions, by the way, if you folks don't. So just so you know. Those are still going to come, but your questions are the most important ones. So let us know down in the chat. And thank you, Hitherings, for welcoming us to Guatemala. I'm going to put it on my list and let you know when I'm going to visit. And we also see Ken in the chat. Hey, Ken, thanks for joining us. Okay, without further ado, Tom, should we get things started?
Yeah, let's kick things off and start with the slides, and we might kind of draw over them a little bit, and
Yeah,
also potentially do some additional drawings.
yeah, we're ready to whiteboard.
Awesome. Are we sharing?
Yeah, we are. All good.
Excellent. Okay. So a quick kind of setup here is what we often see with ISVs, again, independent software vendors that either offer a SaaS application for the customers or have some kind of service or application that needs to consume things from their end customers. we get these two different connectivity patterns, right? The most common one that you've probably seen many times in kind of traditional SaaS applications is I have some HTTPS application as an ISV, and I want my consumers to be able to access it. That's pretty much it. Pretty straightforward use case. The more challenging one is I'm running some kind of service, and my service to operate and to perform its function needs to get access to the end customer's data store, right? Whether it's an RDS database, some EC2 instance hosting some data, or like some on-premise destination, S3, etc. And I will do some analysis on that data so that there's this like requirement to connect in the other direction. So that's I would say it's probably the trickier one to achieve, but we'll cover both. And at each pattern, we're going to have this little legend showing you, is this pattern working for customer to SaaS or SaaS to customer or both?
Nice. One quick question before we go further. SaaS is the software as a service, right? That's kind of what it stands for. And like, what's the connection between SaaS and ISV? Like the ISV has the SaaS, the ISV is the SaaS provider,
Yeah.
right?
Yep.
Okay.
The ISV is the SaaS provider. Yeah. So they're offering software as a service. So a lot of ISVs used to potentially deploy their applications inside of their end customer's environment. Right, maybe run an EC2 instance inside your environment, where whatever that could be, some compute that's going to do analysis, some compute that's going to do, offer some kind of software function. But ultimately, this is a lot of the movement that we're seeing with a lot of our ISVs is those applications are moving to a SaaS option. So you don't have to deploy anything. You're just connecting to an application that the third party is providing to you, and you can consume whatever they're offering.
Got it. Okay, cool. I'm glad we clarified that.
All right. So the first pattern that we see, and that's probably not a lot of people think about it when they think of private connectivity or a SaaS offering. Like the most common pattern for SaaS applications is to have them out on the public internet, right? So you have some kind of load balancer, and we're going to use NLB as the example here because it's the baseline for some of the patterns later on. But it could be any type of load balancer. This could even be an EC2 instance without a load balancer if you want to make your life harder for yourself. But ultimately, you're putting the thing that you want to expose on the public internet and then having your users connect to the internet. The thing I don't have here is CloudFront also could be in front of it. So like you would typically put a content delivery network to help you with optimization. And actually CloudFront recently launched SaaS integrations to make it easier for SaaS providers to be able to, customize the application for different customers and make that deployment easier and be kind of more catered towards multi-tenant deployments, whereas traditionally CloudFront is catered towards a single tenant, just your own application being exposed that way.
Cool. Yeah, I've seen the CloudFront SaaS Manager. I think that's the one you're referring to, right?
That's
That's a
the one.
pretty
Yep.
cool feature. I pasted here the link in the chat if you folks want to read a bit more about it. Makes SaaS management really, really easy. Very, very excited. And it is something that customers have been asking us for quite a long time. So I'm
Yep.
really happy to see that out there.
Yeah, and by the way, when in this session we're primarily focusing on networking, right? So networking for SaaS usually means how do we deal with multi-tenancy? How do we expose applications? There's a whole kind of expertise area in like figuring out multi-tenancy on your compute, right? How are you going to isolate your environments? How are you going to isolate your customers? Access controls, etc. We're not going to be talking about any of that today. We're just focusing purely on connectivity access patterns, which in many cases are going to be similar to what you might want to be doing for your own applications as well.
Yeah, pretty cool. If you folks have questions and if you want to know more about networking for SaaS, let us know in the chat. We might actually have a session where we talk about that. We bring some of the folks who know much more than we do about the SaaS tenancy considerations, and we can have a really good session about that. I would personally be very interested in learning more.
Yeah, so always super interesting to work with customers who do multi-tenancy because that's a hard problem to solve, and
Yeah.
there's a number of different ways to solve it.
And I don't think we've actually talked about reInvent at all. We're not pitching our sessions for reInvent, Tom. What are we doing here? We should talk
Yeah,
about reInvent a bit. ReInvent is coming. So if you folks are going to be joining us there, Tom and I are going to be there, and we would love to talk to you more about all of these cool things. So let us know.
Yeah, we should have like a reward for people that find us at reInvent. So if you're coming and you can find us and say hi, we need to have like a collection of stickers of you found
We
me or
should
something.
have stickers.
Like
Yes,
where is
yes, yes.
Waldo equivalent?
Perfect. I do have a question about this architecture though. So it does rely on public connectivity. Do you often see that there's essentially those security concerns around, well, what is my footprint for securing my SaaS application? Um, Considerations around, hey, I want private connectivity. I don't want internet-based connectivity. Or do usually SaaS providers, or are they usually good with having this as a connectivity pattern?
Yeah, I would say it's a mix because private path and public path, you can probably secure them the same way from a point of view of your SaaS application, right? Use strong authentication authorization, zero trust, TLS, like we use TLS every day to do all sorts of different things, right? Go into a banking app. If that is not secure, then what are we doing on the internet?
Yeah.
Um, but there's an argument of like this forces the end user, right, to build like an internet facing infrastructure purely to be able to reach the SaaS provider. So that's
Mhm.
where I've seen this being a biggest point of friction. It's not necessarily about security of the SaaS providers because again, they can put all sorts of different protections there and ultimately zero trust it.
Yeah.
But it's more about the user now. If there would be a private path to the SaaS provider, I wouldn't have to, as a user or as an application that represents the user, I wouldn't have to figure out a way for this application to be able to get out to the internet and then get to the SaaS provider. I could just have a private path without me having to worry about setting up internet connectivity. So that's what I usually see as the biggest advantage with SaaS access that's private.
Got it. Got it. Okay, that makes sense. And this, as you mentioned, this is a customer to SaaS provider. So I see your packets there moving in both directions, but the connection needs to be initiated by the customer, right?
Yeah, it's request response. Yeah, so the client, there's the user on the right, goes to the application, then the traffic comes back, the response comes back. So that's why there's going to be a lot of animated balls just to make the slides more exciting. But yeah, ultimately,
Nice.
one side initiates the connection, the other side responds.
Cool stuff.
We do have a quick summary here. I'll have these like pros and considerations. I think we touched on all of them a little bit, so I'm not going to spend time on this one, but I'll flash it so that someone's watching on demand, they can kind of read through all of these. I think the one I haven't called out is that it's easy for the SaaS provider to not have to deal with any IP overlaps, right? They don't care as a SaaS provider at this point. You don't care what the IP space is of your client. You're coming in over public IP address space, and that's always um, gonna be unique.
Also, you can use IPv6 and have your SaaS endpoint be available for both IPv4 and IPv6. The internet is 50% on IPv6, and a lot of traffic goes natively over IPv6. So you will want to have that capability.
Yeah, and it's pretty easy to do if you do it on AWS, right? You can switch on dual stack on your load balancers. You can do V6 on CloudFront. Now you can have V6 origins or CloudFront. So there's a lot of magic you can do.
Yeah, exactly.
Okay, so that was the only public connectivity model. So now we're going to switch to private, and we're going to start from the ones that I would say are less common for mass communication, and then we're going to slowly move into the ones that we see more often that are the most adopted ones. So these are kind of included for completeness, but not a lot of customers or SaaS providers actually like these. So in this scenario, we have two VPCs, SaaS provider on the left, consumer on the right, and then we're setting up VPC peering. So ultimately creating like a network to network communication here between those two environments. I think the big challenges of this model is one, you have to have unique IP space, right? So here we have .1, here we have .2. They're unique IP addresses. You won't be able to set up a peering if the IP address schemes are overlapping. And it also means that if this is like you have thousands of customers, all of a sudden you now have a problem to make sure that there's no overlaps. You might need to create a VPC for each customer to make sure there's no overlaps. There's a lot of operational overhead and complexity. Uh, some of the other challenges is that I'm opening access just to this NLB, but from a network perspective, nothing is stopping this client to use the peering and just go straight to the EC2 instance or whatever is my backend compute, or connect to a bunch of random things in this VPC. And the opposite also works. This EC2 instance can use that peering to try and get into anything in this environment, even though that's something I might not want. Right, so immediately you open up this full-blown network access, and now you have to start putting security groups everywhere, which you have to do anyway, but now you need to be sure that they're correctly configured, because if you make a mistake, all of a sudden the SaaS provider might have access to something they shouldn't, or they might give you access to something you shouldn't be able to access.
Yeah. I would say definitely not a preferred mechanism. We do have the customers who are using this model to give access to their SaaS application, but I think, at least from what I've seen, and I'm curious what you've seen, Tom, it's much more common for single tenant SaaS, as in, I have this endpoint, this NLB, and these EC2 instances, and they are serving just this SaaS consumer. There's no multi-tenancy in there. It is a deployment that's dedicated to customer one or customer two or customer three of the SaaS provider. And essentially, the SaaS provider ends up managing a lot of these single tenant environments that have IP addressing dictated by the consumer, that have security dictated by the consumer, and they only deal with that consumer's data, that consumer business logic, etc.
That's right. Yeah, if it's single tenant, then you just keep cookie cutting these environments for each one of your tenants. It becomes extremely complicated if you need to do multi-tenancy, because then you need to find kind of workarounds and potentially combine VPC peering with another solution.
Yeah.
And there's a lot of pushback I've seen both from the SaaS consumer as well as the SaaS provider. But there are some benefits of this model. And one benefit is that if you do need access from like here to some data store on the customer side, that is available, right? You just need to make sure the
Yeah.
security groups allow it, but you can get that access. So if you need this bi-directional, I need a little bit of data to pull from the SaaS consumer, and I need to then connect to the provider. The bi-directional communication just works, but it's ultimately pretty open. So you need to put a lot of like patches to close it using security groups and knuckles.
Yeah, and there's a comment here from Ken for VPC peering option. Are you showing you can route traffic via AWS network firewall somehow? I believe that's not supported. No, not supported. You cannot route traffic through firewall. So you're relying fully on security groups and knuckles and making sure you have the right governance over those.
Correct. Yeah, and then if the other kind of downside here, if you have another VPC, right? So I'm just going to add it here. Hopefully that's showing well. So it's called VPC2, and this is a VPC1, and maybe they're peered. There's no way for me for the SaaS provider to use the peering to get to something in this VPC, even if I would want to expose that, right? Peering is not transitive, so you're kind of stuck with that one-to-one relationship here.
I would say that's actually a good thing from a security perspective, that the peering connection is not transitive, so the SaaS provider can only access things in that VPC that is peered with their VPC. I like that
Yeah, it's the
personally.
simultaneous. If you have a security hat on, it's a pro. If you have like, I need to make this work end to end, and I need to, for the application to work, I need access to all these destinations, then it's potentially a con. But I agree.
Yeah.
It's a nice feature of VPC peering that it actually doesn't allow transitivity.
I would say, as we go through the considerations, one of the things that maybe folks should take after, like, it should kind of remain with after this session, is that the fact that you can do it doesn't necessarily mean that you should do it, uh, because of those security considerations. And I would say probably security is top of mind when you're making these decisions in terms of what is the architecture you're going to be choosing, balancing it, yes, with simplicity and operational excellence and so on. But keep in mind that there's a boundary of ownership here between the SaaS provider and the consumer, and you are trying to sort of bridge that gap, that boundary between these two different accounts, different organizations, different security models, different security policies altogether. And that focus on security, I would say, is probably the most important one.
Yeah, I think that also comes down to the level of trust you have between you and the SaaS provider, right? Because just like with AWS, you can check all of our compliance attestations, like to, get validated by independent vendors, by independent what do you call them? Not analysts. Let's say analysts, so that you can then get all access as a customer available to you in the console in artifacts. So those are usually the things that security teams want to see. They want to have that validation from a third party that AWS is doing what it's supposed to do. So usually for when you're working with SaaS providers, you would often have to go through the same due diligence to validate, okay, is the SaaS provider doing everything they should be doing to secure the environment? Because now if I'm using peering, I've just opened up full-blown access for them, so I want to be sure
Yeah.
that they're doing the right thing.
Yeah. So compliance mechanisms and compliance enforcement and having those security controls becomes really, really important. There's another question again on network firewall. So Mohammed is asking, can be integrated with AWS network firewall? Not peering, not directly. Whatever you have in the VPC that you peer with the SaaS provider VPC, that traffic just flows directly over VPC peering. You cannot route that traffic more specifically through a firewall endpoint.
It's a good call out.
Yeah.
Okay, moving on. Still full-blown network-to-network connectivity, but instead of using peering, we're now going to use a transit gateway. So if you think about the peering equivalent being like a leased line between two data centers, the transit gateway is more like a router, like a hub between potentially thousands of VPCs. But in those scenarios where you're using it with SaaS providers, you typically would just attach that one SaaS provider and then potentially add your VPCs to it. Now, similar to the previous model, bidirectional connectivity. So now we have to kind of add additional controls to make sure that the SaaS provider can only get access to the right things in the consumer side, if that's the access pattern you're opening. And in the other direction, the SaaS provider needs to make sure they're also only exposing the applications that the consumer can get to. In this model, you can add a firewall. So if you add another VPC, or even we've launched a native integration. So actually, let me just remove that. We don't need that. We can just put the native integration here.
Yeah.
So network firewall can now natively integrate with Transit Gateway. So you can just say ANF, AWS Network Firewall, is going to be deployed here for you. You don't have to deal with the VPC. You don't need to set up AZs, etc. It's all done for you. And then the traffic can be pushed through your inspection layer before it gets to the provider, and vice versa. You can inspect that traffic. So that security model is a little bit better because you can put an appliance in the middle that adds a little bit more control, whether it's AWS managed, so network firewall, or if it's a third party, your favorite networking firewall vendor that you can insert into the path.
A really quick question here, and we have some really good questions on in the chat as well. But first and foremost, you have put this transit gateway kind of in no man's land here between these two accounts, right? Who owns it?
Yeah, typically what I've seen is owned by the consumer. So account structure would be this, right? Because that way you're ultimately sharing the transit gateway, and then the SaaS provider becomes just an attachment. They're able to attach to the transit gateway their own VPCs or VPC. And then you control all of the routing on the transit gateway. You don't want a situation where it's owned by the provider, because the provider then can attach. And I haven't honestly seen that model, but that would be the problem with it, and maybe that's why it's not being used. Where if the provider owns the transit gateway and they have like 20 customers on it, they can accidentally allow routing between those customers, or they can again run into CIDR overlap issues, right? In this scenario, we have to have unique CIDR ranges in each VPC, because otherwise this is network to network routing is just not going to work. So if you try to add another customer to the same transit gateway and they might have the same overlapping address space, it's no longer going to work.
Yeah. Now let's take questions from the chat because we have a lot of them. Tech First is asking, SaaS provider must be on AWS for all the connectivity options.
In the examples we have there, yes. But you could be a SaaS provider and be on the data center on premise, and then connect to your consumers on data center on premise. I don't think we would cover that in the AWS networking section, but it's ultimately possible, right? A lot of SaaS providers kind of benefit from being in the cloud, and the same benefits as customers get, right? The flexibility, the elasticity. So the patterns that we're going to focus on today is the SaaS provider is in the cloud. or at least the landing the traffic in the cloud, you could then navigate the traffic back to on-premise if you're in the middle of the migration, etc. But at least your landing, your initial surface that the customers connect to is in the cloud, is in AWS.
Yeah. And in addition to that, though, all of these architectures could be extended, except for VPC peering, of course, because with VPC peering, you peer Kubernetes together. That's it. They have to be on AWS. But for example, for Transit Gateway and what we're going to see next, you can have a direct connect gateway attached to that Transit Gateway, and you could give access to some consumers that are on-prem, right, to these SaaS providers on AWS. The other way around is, for example, when the SaaS provider is outside of AWS, you could connect to them using internet. You could connect to them using some sort of private connectivity mechanism using Direct Connect. You could connect to them using VPNs. Like all of these apply as well if the SaaS provider or the consumer are outside of AWS, with some more connectivity options that allow you to have that layer 3 path routing between the two. Another question. If you have time, show how you can handle DNS resolution. You've put there Route 53 private hosted zones for these endpoints with the SaaS provider in this scenario. Route 53 with private hosted zones or some other DNS magic.
Yeah, I think that's a really good call out, actually. And we will need to touch on DNS, right? So this SaaS application is going to be some app.example.com. If they might have a shared host name, they might have a unique host name per tenant. There's different ways to approach it. And then from a DNS resolution point of view, you need to have some way of being able to resolve this app.example.com and be pointed to this NLB if that's the direction in which you're going. So if this app.example.com is not a public host name, right? So it's not resolving publicly to this NLB private IP addresses, which is possible to do technically. I haven't seen that as a very common pattern, especially if you're going to be sharing this across different customers. You would need to have some kind of private hosted zone inside of this client VPC representing example.com or specifically app.example.com, and then point that into the NLB. The NLB would have its own host name that AWS auto generates. So you would have to do that override to make sure that DNS works in this scenario, so that you know that when you're trying to connect to app example, the IP address you're going to get is that of this NLB, so 10.1, and then all the routing inside of this VPC, transit gateway, and all the components in the path need to make sure that you can get to 10.1.0 something.
Even more interesting, I would say that if, for example, the SaaS provider in this model decides to recreate that NLB or move to a different NLB, and that FQDN of the NLB will change, you will have to update your DNS on your side. So I think we're building up to why these options are not the right ones from security and management
Yeah.
perspective. But yeah, those are all considerations to keep in mind. One
Yeah.
more question.
Mm-hmm.
Can this ANF, the ANF that you drew there, be used for egress filtering as well for spoke tenant VPCs?
Good question. No. So this one is purely for east-west today. If you need to do egress, well, I guess you would still need to have a separate egress VPC. So you can't egress through the ANF VP, the managed ANF VPC. You can egress. So I'm going to draw here an egress VPC, right? That has an IGW and has a NAT gateway inside. So I'm going to put an N. So if I want to go out through the centralized egress VPC, I can get to the transit gateway. I can then have routing force me through the network firewall for inspection and then route out to the internet through this egress VPC. So technically it's doable. The downside here is for using this network firewall for egress as well as for east-west is that you're adding cost. So if you had this firewall deployed in the same VPC, so maybe I have the firewall also in this egress VPC, as the traffic is coming in, it's going out directly. So on the transit gateway, I only paid once for data processing. If I need to go through the network firewall inspection, I'm going to loop back. So there's a charge associated with data processing on traffic coming into the transit gateway, and then I'm going out. So ultimately, I'm kind of going into the transit gateway twice. So I'm paying twice for the data processing instead of once. So it's technically doable. It's just be aware that there's an additional cost associated with with using the network firewall, managed network firewall integration for egress.
Yeah. So I would say ideally you would use this native attachment of the network firewall for your VPC to VPC communication, so east-west inspection, and you would have a firewall endpoint deployed in your central egress VPC. That's the cost-optimized solution. And we also can talk about roadmap on this show, but stay tuned. Um, One more question. We have a lot of good ones. Um, Here we are. Since you mentioned ownership, what about billing, especially for the attachment and the provider side? Who bills? Who's charged for what?
Yeah, wow, these are good questions that are coming in. Let me try and get a different
Yeah,
color because the drawing is getting super messy, but let's try and do yellow. So Transit Gateway bills the owner that's sending data, owner of the resource that's sending data into the Transit Gateway. So whichever attachment I'm coming in on, I'm going to get charged. So account one is paying for the data to the Transit Gateway going this way. Account two is paying for the data coming in this way. So if I'm account two, so the consumer, and I go into the provider and I pull down 10 gigs of data or 10 terabytes of data, the provider is getting billed for all of that. So then they have to have a mechanism to be able to cross bill that back to account two or to the consumer because that's the consumer generating that traffic. So there is a bit of the challenge there for billing. If it's a single tenant deployment, then that's pretty easy because
it's
you
pretty
know
easy.
that this account one is dedicated to SaaS consumer one. Let's give him a number. But if this is a multi-tenant environment, uh, then you now have to figure out what's going on with pricing. But even if this NLB would be multi-tenant, the TGW and the attachment will be single tenant. So that should be pretty easy to be able to allocate and cross-charge that back. It does, though, require some overhead on the provider side. And just
Yeah,
like Alex mentioned, like we can't talk about the roadmap, but we do hear a lot of feedback from customers on like give us easier ways to figure out this cross billing. So maybe in this scenario, I don't want the SaaS provider to be built. I want this to be built to the consumer. Those are the requests that we're seeing from customers, and those are the things that the service team is keen to hear from you.
yeah. And also the hourly attachment cost is charged to the resource owner. So essentially the VPC owner on the SaaS provider side is charged the hourly cost for that attachment. The attachment on the right side for the SaaS consumer is charged to the account that
Yeah.
owns that VPC.
Yep.
Um,
I keep
One more
forgetting
good
about the
question.
per hour because I think that's like $36 a month, and I don't think I've seen
Still
anybody who
there.
cares about that $36. Yeah, it's like
Still
lunch.
there though.
Yeah, it's lunch in New York.
Well, or in San Francisco, let's be
True.
honest. One more question from Mohammed. With TGW, can we have multiple consumers?
Yes, although they would be from the same customer. Let me just
Okay.
clear all of this because it's becoming messy. So you could have multiple consumers, and there would be different VPCs or hanging off the transit gateway. They would all belong to the same customer. So
Yeah,
I haven't seen scenarios where the same transit gateway, because usually the transit gateway is owned by the consumer. So the transit gateway would only be used for that consumer and the consumer environment. So they would control, which VPCs connect to it, which VPCs can reach the SaaS provider. And you wouldn't really have scenarios where the SaaS provider owns the transit gateway. And if they do, it would be a single transit gateway per customer anyway. So those are the kind of more complicated scenarios, but I typically see where it's the end customer managing the transit gateway and then sharing it with the SaaS provider and having the SaaS provider as just another attachment.
yeah. Cool. I'm worried of the time, so
Yeah, I think
I
we.
want to make sure we get to the place where we actually recommend
Yeah, yeah,
customers go.
yeah,
Cool.
yeah. We don't want to end up. So I skipped through this considerations because I think we went off through all of them. Yeah, now we're getting to a point where these are the things that we do recommend SaaS providers and customers use because they give you the right level of control, security, isolation, and remove some of the pain points that we've seen earlier that everybody on the chat was kind of calling out as well. So private link, also called VPC interface endpoints. Private link, they sometimes used interchangeably. So we say private link, and today private link is the technology under the hood that powers endpoints. And there's different flavors of endpoints that you might see, and we'll touch on some of them in the session. The first one is the interface endpoint. So with the interface endpoint, we're ultimately doing just the consumer to the provider. So the provider has some sort of app, and let's imagine it's a HTTPS application. So they'll have port 443 on the NLB, TCP. The NLB, it has to be NLB for enabling interface endpoints. If you do need application load balancer in the path, you would have to put it behind the network load balancer. And then normally a network load balancer has this listener on port 443. And typically that listener would be just in VPC on the left in account one. So say VPC1, VPC2. That listener would just be on the NLB in VPC1. With private link, what we're doing is we're allowing you to create kind of like a long arm, like an extension of that listener that can be popped into the consumer VPC. So this interface endpoint is ultimately a network interface. It will get an IP address from the VPC range, which is 10.1.0, maybe 15. And this other one is going to be 10.1.0.27. Actually, they're in different subnets, so they probably would be way different. And then both of them are going to be listening on the same port that the NLB is listening on. So you have 443 listening on this interface endpoint. So as a client, I just connect to port 443 and I magically get transported to the NLB, and then NLB takes care of the rest. So delivers the traffic to the appropriate destination.
I like to call the interface endpoints or private link technology overall, like for those of you passionate of physics and space-time travel and stuff, I like to call it a wormhole because it's kind of like folding space-time and getting you from a different VPC, different account altogether into that NLB essentially.
So I think we're going to disagree here because I like to call the gateway endpoints the wormholes, right? Because
Oh, I
they are
see.
like a
Interesting.
they're actually like a portal, right? That to me is a wormhole.
I
And I
see,
guess
I
we can
see.
we can argue, right? If this is a S3 gateway, then that's kind of like a magical wormhole to the S3
Mm,
world. Yeah,
okay.
this is more like a teleportation, or yeah, I don't know. We need to find a good space analogy.
Nice, nice. There's a question here. Both sides should be in the same region
So that used to be the case, not anymore. You can do cross-region private link, something that launched a few months ago.
at reInvent. Yeah,
Yeah,
at reInvent last year, I think.
yeah.
Yeah.
So you can, this account too could be in the VPC in a different region, and you'll still be able to establish this connectivity. So it's nice for a SaaS provider to then, if I have a multi-tenant environment, maybe I just put it in, Ashburn or in the US East 1. But I have consumers in US East 2, but not a lot. My majority of customers are US East 1, but I also want to be able to offer that service, but without having to deploy the whole infrastructure. So now you can just do cross-region interface endpoints and allow that traffic to come in cross regions without you having to deploy additional infrastructure.
I would say though that there is additional considerations if you're doing cross-region. Keep in mind that you are taking or essentially introducing cross-region dependencies. So keep that in mind and do it wisely and carefully and make sure you're aware of it. Um, And yeah, I pasted here in the chat the link to the blog post that talks about how you can use cross-region private link, what you need to do. The cool part is that you don't have to recreate any of the infrastructure. It works with existing endpoint services that you have associated to those NLBs. You just have to make an API call to update the regions where those endpoint services are available for clients to create interface endpoints. So that's the consideration
Yep.
about cross-region private link.
Yep. Some additional things here that you may have already noticed. IP addresses can overlap. Connectivity is unidirectional. It doesn't mean that you can't flow in both directions, but you can initiate connections only from the consumer to the provider and only on the port that you're listening on. So there's no way for consumer to try and connect to an instance or to anything else but that NLB, and only to the ports that this NLB is listening on. Nothing else is going to get passed through.
Mhm.
And then finally, I know we talked about DNS. So when you create these interface endpoints, they will come with like a default DNS, VPC dot something dot Amazon AWS.com. So there will be a default DNS name that's created. If you want, as a SaaS provider, you can have a custom domain name that enabled on the service. And then whenever a customer creates the endpoint, they can select, hey, I want this magic of private DNS to work inside of my VPC. And again, let's say this is app.example.com. That's the host name that the service is registered with. If I'm a consumer and I deploy this endpoint and I say, I want this private DNS to work, we will magically make it happen in that VPC. Wherever you do a DNS lookup on appexample.com, you'll get sent back to the endpoint. So DNS kind of becomes automatic for the VPC that you have the endpoints in.
If the SaaS provider does go through the DNS verification process, right? So they have to have that domain name for their application be a verified domain name and put that TXT record into the host name, into the hosted zone that they have and they own.
Yeah, they have to prove that they have ownership, right? They can't. They wouldn't work for any random domain name because that would be a bit of a security risk too, right?
Yep. There's one super good question from Ken. Regarding the private link security group, do you need to set both inbound and outbound rules or just inbound rules? Tom, do you want to go ahead and show us where all the security groups that you can configure are?
So I know they could be around the endpoints,
Yep.
right? And usually, because this is pretty much inbound only, the
Hmm.
endpoint accepts connections, but it wouldn't initiate connections. Typically, security groups would be just some inbound rules. I know we launched on the
Yeah.
NLB the set of security groups. I can't remember what we're looking at there.
It's the
If we're
actual
seeing,
client IP.
okay, yeah, that's good to know. Um, so as the provider, you can set up a rule based on the client IP. Have you seen that being used very often? Because I think in the multi-tenant environment of SaaS
Yeah,
providers, I think that's,
not really.
yeah, it's pretty
Yeah.
tricky because you'll have everybody kind of overlapping IP addresses left, right, and center. So I
Yeah.
think this might make more sense if you're just deploying it for your own organization and you have some IP space control.
And the cool part about that is that with NLBs having security groups, you can control, you can tick a tick box, you can make an API call to say if you want private link traffic to be subject to inbound rules of the security group, or if you don't want that. So those inbound rules on the NLB would just be meaningful on the VPC side or on your internal network, essentially not for traffic coming through private link.
Cool. Any additional questions on the private link? I think that's a pretty mature service. We had it for maybe 4 or 5 years now.
Yeah, yeah. Customers love it. It's super adopted, super good. We hear a lot of good things about Private Link. Let us know if you do have feedback or questions about Private Link overall. If you would like to see a session dedicated to Private Link, we'd love to do that. There's one more super quick question on the provider side. VPC flow logs. Can we see the end client of the consumer? Does
On
that
the
NLB can do source IP preservation?
Yeah, so you won't see that in the flow logs. So in the flow logs, you will see the NLB talking to the backends.
Yep.
Uh,
But
the NLB
the
also
client
doesn't,
IP, yeah,
yeah, yeah, the NLB doesn't preserve the client IP either. The only option is to do proxy protocol version 2, PPv2,
yeah.
something you can enable on the NLB because the NLB is TCP, so it's not, the NLB doesn't understand the application layer. Typically with HTTPS load balancers, you would add the client IP into an additional HTTP header, but the NLB might be transporting like TCP traffic that's maybe HTTP, maybe not HTTP, so it has no way to like make any changes in the application layer. So proxy protocol version 2 operates on the TCP layer. What it will actually do is it will wedge information about the client IP and I think VPC ID
Hmm.
into
Yep.
the TCP segment, and it will when it gets to the final destination, if you don't enable proxy protocol version 2 on your destination application to be able to parse proxy protocol version 2, it will look as if it's malformed TCP and it will just get dropped because it if you don't know it's PP version 2, proxy protocol version 2, is going to look like junk and it's just going to
Mhm.
get dropped. So once you enable it, you need to make sure that all of your backend applications also expect to receive proxy protocol version 2 in the TCP payload.
Yep. There's one more question from Tech Fuel, which we're going to take once we get to Lattice. I acknowledge the question and would love to dive a bit deeper into that. So yeah, what is the oh, there's one more question from Ken. Asking when the private link is created, the private DNS hostname is present, but after some time, there's not there anymore. It's very strange and resolution is not working anymore, or the private DNS is enabled. It seems to be some operational bird churn there. Ken, I would highly recommend you would open a support case and you would have AWS support have a look at that. Um, we're happy to chat also on a call. Make sure you don't have these issues. But yeah, support case is your best friend at
Yeah,
this point.
yeah. Very quick, the biggest challenge of this model is this directionality, right? So
Mhm.
whenever we had SaaS providers needing to talk to the consumer things, they would often ask the consumer to put an NLB on their end and then point that to a database and point that to something on their end, which is a pretty kind of, I would say, suboptimal experience for the consumer, for the customer. Um, Oops, animation. So that's where we came with some of the new launches from last reInvent, uh, resource endpoint, and then Lattice. And we'll have a discussion of kind of when to use which one and kind of what they do. But the resource endpoint is, I would say, there's less components, so it might be easier one to start with, and then we can talk about kind of the one that's probably more flexible option. So with resource endpoints, as a provider in this case, so you see the consumer is now the ISV, the provider is the customer. So the roles have reversed. And I know we're saying here it's the provider of the service, but it's not the provider of the resource that we're going to be consuming. And then in here, what the customer needs to create is this resource gateway. So that's step number one, right? They create a resource gateway. Resource gateway is a new object, and it will have interfaces inside of the subnets and availability zones that you specify. And it will get IP addresses from the respective subnets. And then what Resource Gateway is ultimately used for is as a jump-off point to get into things in this VPC, as well as get into things anywhere this VPC can reach. So as traffic is going to be coming in from the ISV, it will just come out source knotted to this IP addresses inside of the VPC and then be able to connect to applications that were exposed to the ISV. What the ISV needs to do is the ISV creates a new type of endpoint, resource endpoint, that also will have a network interface. And also the ISV will be selecting the subnets in which these endpoints need to live. And they will be grabbing IP space from those subnets as well. So you need to make sure that these subnets are big enough because there might be quite a few IP addresses that you might need to dedicate for access. Each application, each resource that you're sharing is going to need a single unique IP address from each availability zone. So if you're thinking I need like hundreds of resources, you will need to make sure there's enough IP space for that.
And
So that's your
for those
infrastructure.
resources, for those resources, you do so that resource gateway can't just go and talk to anything. You have to define what you want it to talk to, right?
Correct. Yes. So right now, this is the underlay, let's say, or the plumbing
Mm-hmm.
that you need to build for this to even work. And then the final step is to say, I want to define the resources. And with resource endpoints, you would define a resource group because you can only share one thing through this model. And you either share a single resource, which is not very exciting, or a resource group that could include a bunch of different resources of the same type. And what we mean when we say resources, we mean either IP address or a host name or an ARN or a resource identifier for AWS services. Today, that's currently only RDS.
Yeah.
So I want to highlight really the host name option here. That is a very popular pattern, and that's pretty much the first service I think that we have that allows you to target a host name.
Yeah.
right? In all the other services with load balancers, you target IP addresses, you target instances. Here, what you're saying is, maybe I have an application on this end where it's app example.com, and that resolves to IP addresses 1 and 2 of these two, 1 and 2. I can share this host name as a resource in the resource group. So there's going to be my resource 1, a child resource, that's app example.com. And that resource will ultimately receive a unique IP address from this VPC that the client can access. So if the client connects to this IP address or this IP address, the resource gateway knows, or the resource endpoint service knows that this is mapped to appexample.com. Traffic will flow to the resource gateway. In the meantime, we'll actually do a DNS lookup on the fly to check, oh, what is appexample.com? And we're going to get back IP addresses 1 and 2. And then the resource gateway is going to assign one of those IP addresses to each flow. So maybe the first TCP connection comes in and will land on 2. Next one goes on 1. Next one maybe again on 1. And it's kind of distributed at random, but at scale, it will give you like a better distribution of load between different targets. So ultimately, what you're doing here is you're exposing something that's accessible as a host name or an IP address to this consumer VPC in this scenario. In this case, it's the ISV.
There's a good question in the chat. Same thing can be done with private link model, right? Like, is there any advantage of using the resource gateway? And I think from the DNS name perspective, that's really useful when that resource lives somewhere outside of AWS, maybe on-prem or in a different cloud. But if this model is really good for when you don't need load balancing, you don't want to get to that place where you would put an NLB in front of your resource, because if you can put in an NLB, you can just do private link, right? You don't have to do resources. This is an optimized way of exposing resources that are not load balanceable, right?
Yep. So you could still, in theory, point to a load balancer, right? So the host name that you're targeting is a load balancer, so you can have an NLB. But again, as Alex said, at this point, you might as well expose that as a private link endpoint instead of through the
Yeah.
resource gateway. Because from a kind of end-to-end cost point of view, ultimately, it's going to be pretty much the same. So the biggest benefit here is that you can access a host name. So if I have something that I can only target as a host name, this becomes super interesting, because then as IP addresses change of that host name, we will automatically detect that it's changed the logic of forwarding, right? So if my appexample.com today is 1 and 2, tomorrow I'm adding more instances 3 and 4, that will get automatically reflected in the host name, or automatically you will need to make sure that this is reflected in the host name that the resource gateway is pointing to. But we will do a DNS lookup, discover that 3 and 4 are now also an option, and start using those for your traffic. And then maybe 1 and 2 go away. As long as you'd update your DNS name, we will also make sure that a 1 and 2 are no longer available. We will stop sending traffic, or we will no longer send new connections to those destinations.
Um, because we're talking about SaaS providers and ISVs, a super common use case for this is, for example, when you want to expose a database to your SaaS provider, or a data store, or an RDS database or a database, whatever it is, or your EC2 hosted database, where you have most likely an active node, a read write node, and a read replica node, and you get those DNS names on AWS. But if you were to expose that database, for example, through Network Load Balancer, you had to go and say the IP destination and this target group of the Network Load Balancer needs to always be in sync with what the read write node is. And if there's any failover happening within the database, you would have to go update that target of the NLB. You don't need to do any of that here. You just need to specify the ARN, the AWS resource name of that database, and that works, or the DNS name that you control for your EC2 hosted database. So it's much cleaner in terms of the components that you need to do, the operational aspect, and how easy it is to expose these resources. We only have 5 minutes left, and I
I
want
know.
to make sure we get to
Let's.
the last option.
So yeah, there we go. Last option. the right side stays the same. We have a resource gateway. We have ENIs for that resource gateway. But this time, instead of creating an endpoint directly to the resource gateway or to the resources behind that resource gateway, we will use Lattice. So Lattice has another component in the middle. That's going to be the service network, which is going to be the container for anything we want to expose to our consumer, in this case, to the ISV.
Mhm.
And then we'll do a different type of endpoint to access that service network. It's called the service network endpoint. And it operates in a very similar way. As once this kind of end-to-end infrastructure is built, as the customer, as the provider, I can just keep adding the applications that I want to share. Up one, maybe this is a host name that I'm sharing.
Mhm.
Up two is an IP address that I'm sharing, and I can mix those now. So I can throw in anything I want into the service network as a container of things that I want to expose to the ISV, and all of them will work. So this next one could be just an ARN. So this could be an actual RDS database,
Mhm.
or you can add additional groupings. And if you really want to, you can also add services here, which Lattice also supports. But we're not going into those details. So all of this access that we're currently focusing on today with the time we have is going to be TCP based. So these are all TCP connections. We're not focusing on specific application layer constructs that Lattice also supports.
But you could always add them if you wanted to. You could add services in there. You could add for that bidirectional kind of connectivity model that we were talking about. If this SaaS provider, for example, the ISV also has an endpoint that they want to expose to you, they could also attach it to that service network. There's a really good question in here around the service network, to who it belongs to the consumer or to the resource provider. There's multiple models here, right?
That becomes more blurry, and it's interesting. So I like to think about it as a consumer owned, because there's a consumer. I could think about it. I have multiple ISVs, multiple providers that I need to share things to. So I create a service network for each one, and I throw all the things that consumer should be able to access, that ISV, that third party, and then I can share the whole thing with them, and they can connect to it. And if tomorrow I decide actually they shouldn't access the database, I just remove that database from that service network and I cut off access. So it's a
Yeah.
really nice way to be able to clearly audit which third party that's accessing my things through the service network has access to what specific application, and then be able to cut off this access. First of all, audit, and then cut off this access at any point in time. So it's very
Yeah.
easy compared to like the previous models were all very based on IP addresses, which are not a great way to keep track, because in 5 months, in a year, your security groups, you might not exactly remember what was behind some of the IP addresses that you open access to. So it
Yeah.
becomes a little bit harder to audit. Whereas with this model, it's an application by application exposure, which is then very clear to understand what you were trying to do, what you were trying to expose.
Yeah. We're getting really good feedback that we need another session and we need part
Yeah,
two of
yeah.
this. Would love to, and I think we do need to talk a bit about the architecture options and more about the pros and cons of these different options. So yeah, really, really exciting session today. We are almost at time. Folks in the chat, thank you so much for sticking around with us to the end. We've gone through a lot today. We've talked a lot about a lot of things. Please reach out on LinkedIn, socials, anywhere you want to share questions. If you have also questions about like architecture things, there was a question from Tech Fueled around gaps and limitations with Lattice across VPC resource access. Please do let us know on LinkedIn. Contact your account team. We can have meetings. We can dive into these architectures with all of you folks. And yeah, thank you so much for joining us today. Thank you, Tom, for your time and the awesome slides and whiteboarding. And looking forward to our next session next week, right?
Yep, I'll be there, and see you guys next week.
Awesome. See you next week.